Hi everybody. Welcome to the first lesson in the second half of the course. In the second half of the course, we're going to be looking at inferential methods. And in statistics, statistical inference is a huge part of what we do. This is how we generalize or make inferences from the sample to the population. So for example, if we know the sample mean and we want to know something about the population mean, that's a statistical inference, and we need these tools to do that. So the two main tools we're going to be using are confidence intervals, so we're going to learn about those this week, and hypothesis tests, and those are coming up starting next week for the whole rest of the course. So we're going to have a lot of fun with hypothesis tests. So a confidence interval, is what we're going to be doing this week, is an interval that we are some degree of confidence, usually 95%, but it could be other values as well, contains the actual value of the quantity we're looking for, like the population mean. And this is needed because there's something called sampling error, which I think we talked about at the beginning of the course, but I'll remind you anyway. It's not a mistake. It just means that if we take a sample and find the mean, that's not going to be exactly the same as the population mean. It should be close, but it's not likely to be exactly the same. So confidence intervals tell us about how far off we think we are. So confidence intervals can be written in this form, which I refer to as margin of error form. Point estimate plus or minus margin of error. And I'm pretty sure you've seen this kind of thing talked about before. You know, around election time, they'll say candidate X is beating candidate Y by 3 points with a margin of error of 2 points. And you know what that means. You know that means that they think their estimate could be off by the margin of error in either direction. And so the two points here, the two parts of this formula is the point estimate, which is our best guess for the thing in the population we're trying to estimate. For today, we're looking at the population mean. So our point estimate, our best guess for the population mean is going to be the sample mean. So for today, our formulas look like sample mean plus or minus some quantity that we think our estimate might be off. And we're going to have formulas for those, which you'll see in just a minute. All right, so big picture, we're looking for an interval that we're pretty sure contains the value of the population mean. So now we're ready to start in section 8.1, which is the confidence interval for the mean. And in this section, we're going to assume that we know the population standard deviation. Okay, so this is what's called the Z interval. So taking us back to the central limit theorem, we were looking for probabilities relating to X bar. And we said that X bar minus mu over sigma over the square root of n was a value of Z. So if we want an interval that includes 95% of those values of Z, we need to use the values plus and minus 1.96. And the way we find that 1.96 is, if you remember, if we want 95% in the middle for Z, we have to do 1 minus 0.95, and then divide that by 2. And then we're looking for the inverse normal of that. But we need to make sure we keep the positive. So we'll make that negative. So that value gives us 95%. This is the value of Z with 95% in the middle. And by the way, if we wanted that to be 99%, Now that we've got this like this, we could just change that 0.95 to 0.99. And this is the value of z we would need. If we instead wanted 90%, we could just change that to 0.9. And this would be the value of z that we'd get. So if I were you, I would set up an Excel file just like this, and then you don't have to do this calculation every time. So if we were to do some algebra, and I won't make you watch me do the algebra, but if we were to do some algebra and solve this for mu, we would get this formula. And by the way, I also changed 1.96 to z. Don't worry about this alpha over 2. That just means this particular value of z, where we've got the confidence level in between the two values of z. So anyway, so if I solve this for mu, I get this formula. And this is the formula for the confidence interval. So this z times sigma over the square root of n is your margin of error. And don't forget that this formula requires that we know the population standard deviation. So we already talked about this a little bit, but just again, how did I set this up? I wanted a 90% confidence interval, or I started with 95. So I needed a value of z where the confidence level would be the probability between negative z and z. And if I get my handy dandy pen, so I'm looking for the value of z where there's negative z and here's positive z, and we've got the confidence level is the probability between them. So if we want this to be 0.95 for a 95% confidence interval, 0.95 is in the middle, and that means we've got 0.025 in each tail. So we first need to find 1 minus this confidence level, divide it by 2 to get the amount in each tail. So that's what we did here. We did 1 minus the confidence level, and then divided it by 2, and that goes in this cell. And then to find the lower value, we just do norm S I and V of the 0.025 over here, this lower limit. So this 0.025. But that'll give us the negative. We want the positive. So we change that to, we just change the sign on it. So this will always give you the value of z you want. So let's do an example. So in a sample of 100 recently sold homes in the city, the mean sale price was $183 per square foot. And we're assuming a population standard deviation is sigma, of $20 per square foot. And we want a 95% confidence interval for the mean. So in this problem, 183 is based on this sample of 100 recently sold homes, so n is 100. 183 is x bar. The population standard deviation, sigma, is 20, and we want a 95% confidence interval. So if we plug into this formula, x bar is 183. And that's going to be plus or minus the value of z, which we can get over here. If this were 99%, we'd put 0.99 there. And we'd use the value of z, 2.5758. But here we want 95% because they asked for 95% in the problem. So this is 1.96 rounded to, if we round this to 4 decimal places, it's 1.96. You're not going to have to worry about rounding anyway, though, because you're going to refer directly to this cell. So this is 1.96 times sigma, and sigma is 20 over the square root of the sample size, which is 100. And so then we just need to figure out what this calculates to be. So 183 plus or minus so that's going to be the 1.96 referring directly to that cell times 20 over the square root of 100. So this is our margin of error. So 3.9199. So this is our answer written as a in margin of error notation. We should also write it as an interval, where we've got, parentheses. And let's just figure out what that is. So 183 minus the margin of error, which is 179.08. Up to the top of the margin of error, or the upper limit, which is 183 plus this margin of error. So 186.92. Okay, and I realize this says plus or minus, but that doesn't mean you do the plus first and then the minus. You always write this as lower limit, so it's always lower, comma, upper. Okay, this is an interval. All right, so this is our confidence interval. So the margin of error notation tells us that our best guess for the price per square foot is 183, and we think it might be off by 3 well, this is money, so let's round it to the nearest cent. $3.92 per square foot. This interval tells us that we think the population mean is somewhere between 179.08 and 186.92. Let's talk about interpretations, though. So every time you do a confidence interval, you should write a sentence of interpretation with it. Okay? I will count off if I ever see a confidence interval with no interpretation. So there's not a lot of leeway when it comes to that, though. There are a couple of ways we could phrase this. One is, we are 95% confident that the mean price per square foot for all houses in this city is between 179.08 and 186.92. About the extent of your leeway is to change that from we are 95% confident to with 95% certainty. Okay. Let's talk now then about some problematic interpretations. Okay. And by the way, if all you do is write this, you'll be fine. You just need to put the right percentage, the right context, is what is it the mean of, and the right numbers. All right? But I do need to tell you, these are problem interpretations here. And we'll talk about why. So for the first one, if we tried to say that the mean price per square foot of all houses was between these two values, the problem there is that this statement here, number one, is too certain. We don't know that for certain. We're only 95% confident that's the truth. So we can't state it with that amount of certainty. So you have to leave yourself that amount of wiggle room. All right, so this would be bad. Okay, so don't do this. Making a point of marking through that just so you know that's bad. The second one that's bad is to say that we're 95% confident that the mean price per square foot for all houses falls between those two values. The problem there is the word falls. This word falls makes it sound like the population mean is a random variable. It's not. This word conjures up, for me, like a marble spinning around on a roulette wheel, and eventually it's gonna fall somewhere, it's gonna drop. Well, that's not what's going on with confidence intervals at all. With confidence intervals, the population mean is fixed, and so we to be the right color. So the population mean is fixed, so we don't want to make it sound like it's moving around. So instead of falls, you could say is in the interval, is contained within, is captured within, is included within, but there's not a lot of option beyond that. But just avoid the word falls. Third problem. We are 95% confident that the mean price per square foot of all houses in the sample is between these two values. The problem there is the word sample. And the reason that's a problem is that, so the reason the word sample is a problem is that we know the sample mean. We were told it in the original problem. The sample mean is not what we're trying to make inference about. It's the population mean we want to know. So, leave out that word sample here. Okay? And don't do any language equivalent to it, like the mean price per square foot of the 100 houses is in that interval. Okay? So that's the problem there. Lastly, it's incorrect to say that 95% of all houses cost in that interval, because that's not what we found. We found 95% confidence that the mean is in that interval, the population mean is in that interval. We don't know anything about the proportion of houses that are in that interval. All right? So that is it for this lesson, and I hope if you have any questions, you'll feel free to let me know. I just want to cross this out before we go, so that you'll see these are not correct interpretations. All right, that's it for this lesson then.